Simplifying complex numbers. Our essential question is, how do I simplify square roots with negative radicands? So to understand imaginary numbers, we're going to consider what is the square root of negative 25. And I think we've talked about this before. Well, the square root of positive 25 is both 5 as well as negative 5, because if I square both of these terms, they'll give me positive 25 again. So how do I get the square root of negative 25? Well, that can't be done in the real number system. It's non-real, which brings me to the definition of a new number. It's the number I. I is defined as the square root of negative 1. So this little meme says, I love math. Technically, an imaginary number is a multiple of a quantity called I, which is defined by a property that I squared equals negative 1. Well, if I squared is equal to negative 1, if we took the square root of both of these, that would leave me with, this would undo each other, I equals the square root of negative 1. So this is our most basic imaginary unit. The square root of negative 4 is undefined in the real number system, but it exists in the imaginary number system. So the moment we say imaginary, kids always think they don't exist. They're just poorly named. So let's simplify the square root of negative 81. Okay, well, using the quotient rule, I know that this is the same as the square root of negative 1 times the square root of positive 81. We now know that this is defined as I, and the square root of 81 is 9, so this is best written as 9i. Let's do another. Square root of negative 50. Well, I could break this into negative 1, and then I think about my perfect squares that go into this. That would be 25 times 2. So that radicand is still negative 50, and I can simplify each of these. So the square root of negative 1 would be I. The square root of 25 would be 5, so I'd have I times 5. And then the square root of 2 is irrational. It would stay beneath the radicand. The best way to write this would be 5i times the square root of 2. Now, you will see some places write this as 5 root 2 where they put the I last. My fear is it'll look like i's beneath the radical sign, so I prefer this first way. Let's do the square root of negative 72. So again, thinking about, well, what perfect squares go into this? That would be, let's see, I have negative 1 times 36 times 2. The square root of negative 1 would be I. Square root of 36 would be 6. And again, root 2 is irrational, so best written as 6i root 2. So for the next one, I have a coefficient. This would be 5 times the square root of, break this up, negative 1, and then trying to find 192 that goes into 192. Let's see, 1 goes into this. Always. 4 does, but I'm going to check something bigger. I try 16 if 4 does. 16 goes into it. So if 16 and 4 do, I'm going to actually try 64, and 64 goes into this 3 times. All right. And I wrote 63. I meant to write 64. Okay, so this becomes I, square root of negative 1, times square root of 64 would be 8 times root 3. So to finally simplify this, I'm going to multiply my coefficients back together to get 40i times the square root of 3. So let's look at how this fits with the real number system. So we did the real number system where we broke it into integers, natural numbers, whole numbers, etc. So if we just consider that whole graphic organizer is in here, this includes imaginary and rational. Pure imaginary would be I, 2i, anything with I in it. But now when we take a real number and an imaginary number together, we get what is known as a complex number. So complex numbers include part real, part imaginary. So this is an example, 3 plus 2i. It kind of looks like a binomial. This, if you simplified it, would have an I. Those are complex. So we're going to express each of these as a complex number in this form of a plus or minus bi. So I'm looking at this right here, and I can break down root of negative 36, this again would be negative 1 times 36. So this becomes 6i, and we copy the first part. And I look and see if I can simplify this any further. They are not like terms, so I am finished. This is a complex number, and it matches this form. Next, root 15. Well, this would be negative 1 times 15. And I don't have any perfect squares that go into that, so the only thing I can simplify is this right here. So I'd have 13 plus 2 times I times root 15. Try this one. So what I can do in this one is simplify root of negative 9, and that's 3i. So that would give me 19 minus 24i. Let's just take it one step further and consider what would I squared be if I is equal to the square root of negative 1. If I square both sides, I would be left with just the radicand in this scenario. So I would be equal to, or excuse me, I squared would be equal to negative 1. So what would I cubed be? Well, this would be the same as I squared times I, if you think about your exponent rules. And we just said I squared is negative 1, and I is the square root of negative 1. So this would be negative 1 times the square root of negative 1. Or I to the fourth, think of this as I squared times I squared. This would be negative 1 times negative 1, which would be positive 1. Take a second and just enjoy this cartoon. If you have any questions, please reach out. It's time to do some practice.